I have a rather small obsession. Some of you share it as well. Today, I would like to emphasize my obsession with the goal of either achieving big numbers in terms of speed, I think it actually tops out at like, or likely repair costs.
Completely gone.
Several companies providing support, and as always, questionable design choices, I would like to welcome you to this episode of Voron Limits. So what are the real goals, first of all? Okay, well, I want some fun, and based on your presence, I'm hoping you do as well. Secondly, I want to practice using Nema 23s, designing stronger parts, trying other popular designs, and most importantly, I want printer to go brrrr. Seems simple enough. Here's the timeline. First up, print the parts required for the Tulip Gantry conversion and Showoff toolhead. Mini Stealth Burner was temporary at best, and I'm looking forward to having a proper extruder installed. Hello Orbiter V2. We're going to need it. As for Tulip, well, belt tensioners at the front so I don't have to move the motors, and double shear built-in were top candidates. Although I'm pretty sure 6mm spec belts aren't threatening an 8mm Nema 23 shaft. But still, why not? Practice and experience is good. I even have more metal parts to install alongside these upgrades to hopefully build up the machine to the point where we can print and see if anything snaps. The first thing we are actually installing is this CNC bed mount. Let's get to work. A quick disclaimer, these companies provided support for this video and there is an ad read between these two time points. Please take this into consideration. All right, first up, let's get rid of the door and the top hat. Not bad at all. Perhaps a little clean could be nice as well. So this is the CNC bed mount for the V0 from Fysetc. That is metal. That is a big block of metal. I love metal. Let's see how far I can make it without instructions. We should be able to just, yep. Alrighty, I'll be very pleased if I don't have to disassemble anything further and can just uninstall this, slide in the new one. I think we might be able to. Now, don't get me wrong, I love metal. Sheet metal, die-cast metal, pressed metal, absolutely anything. All the types too. Maybe not 10, 10's all right. Anyway, I digress. This is just not as strong as this, straight up. And yeah, that checks out. This is like 8mm machined aluminium, I'm pretty sure, and it is beautiful. And on it goes. We need to print this thing here. We need to print a different one. We need to do some heat set inserts. Why is it not turning on? I've never crimped these small JST connectors, so let's see how it goes. I bought some big ones for the Nema 23s that I'm excited to try. All right, someone might need to help me out with the terminology, but in this piece here, there's a bit of a depression. Bit tricky to see. Now you can see it there, there's a bit of a depression there. And what's neat about that, there are some positive pieces there. I don't know the term, sorry, someone might need to correct me. And they interface together and they don't move up and down. Once it's in, it's in. That's so smart. I need to take notes here, honestly. I am so bad at CAD. I pride myself on my ideas, but my executions leave quite a bit to be desired. I'm quite sorry about that. Well, with more practice and more time, things will keep improving. Yeah. Whoa! That was a little bit fiddly to install, but we have it on now. Sweet, those are the perfect length. We've got the bottom screws done. This is looking really neat, and it feels pretty solid. I think it's time to start adding the springs back. The slots that they go into, that's quite a nice add-on. Okay, I hope I don't butcher this too much. Just be nice and slow. No, that wasn't as hard as I thought. Nice. Honestly, all things considered, that wasn't very hard at all. It is now time to install the Tulip Gantry. I think I've got all of the hardware here. We've got the printed parts, hopefully, and then the manual, which was a huge deciding factor for going with this. I'm so glad there's a manual. Let's see how far I can make it without instructions. Oh, I love pins so much. These are so nice. I just love metal. First step, we're gonna have to do some disassembling. Goodbye, Mini Stealth Burner. I enjoyed every second of that. If I had to be qualified to talk about all of these components, I'm pretty sure most of my videos would be silent. All right, that's the tool head gone. Now we need to remove the belts. It hurts because this was such a pain to do, installing the belts, but has to be done. And we get to replace this part with metal. You may know the saying, does more expensive mean more better? But my question is, does more metal mean more better? Let's find out.
Welcome to Donut.
Okay, I say that, but I'm not gonna do any testing at all. As long as this survives, that's a win. And while I'm not sure if I've spoiled this already, I'm not gonna spoil it if I haven't. These panels have gotta come off. I absolutely love doing these upgrade videos, but in the long run, hopefully once YouTube money and all that kicks in, one day I would love to do videos like full steel Voron, full carbon fiber Voron, maybe even full titanium Voron. But yeah, just gotta pay the bills first. Now that's a joke, I spend all my money on Triangle Labs products. 3D printing is such a brilliant hobby because it combines mechanical engineering, electrical engineering, programming. It messes around with heat and air. Oh, I absolutely love it. I think that's so cool. And when you work on things and improve things and all that, it has real benefits. Absolutely incredible hobby. Drives me mad though. Oh right, yes, when I mentioned Triangle Lab, yeah, I also spend all my money on stuff from Big Tree Tech.
I nearly dropped one of my road guys in my cup of tea, so yeah, I'm calling it for the day and recharging. See you guys tomorrow.
When I unplug this, everything falls down. Everything still works, so that's good. Nice and secure. These motors are absolutely tiny. You know what? Let's roll the unboxing montage now for the Nema 23s, and I'll show you just how small they are.
It is finally time to unbox the motors from StepperOnline, which they've kindly sent over for this video and another. But look at this box. It's the same size as the Voron itself. Let's put it on its side. And not only that, they weigh pretty similar too, which is awesome.
Enough talk, let's unbox.
Oh, some stickers.
I love stickers. I think I know what this is. Oh, this is cool. They included a spec sheet for the motors. This will be handy. So, under this piece here.
Yeah! Wait, these are awesome. I've never seen Nema 23s before.
So these are huge. I'm gonna put this guy here. Let's grab the others. Absolutely phenomenal. Next layer. Yeah, these are not getting damaged in shipping.
Oh, this is beautiful. Check that out. I'm hyped for Nema 17s, but these? I'm just blown away.
Final one. Having 6 of them in front of me just like this, absolutely insane.
Check out this cube of motors. Absolutely insane. These weigh like, what, a kilo each? How much do these weigh? These literally weigh 1.1 kilos each. All of these weigh as much as the printer. However, we are installing 2 of them. The other 4 are going on something monstrous.
Now, this is actually my first time seeing a side-by-side comparison. The AB drives are helping it a little bit. Let me uninstall them actually. And I am aware that we could probably max out the cooling and flow with Nema 17s, but yeah, going from 14s to 23s, that's a jump, and I'm all for it. Now, I was almost going to remove this back panel here, this one. However, looking at the CAD, we have just shy of 1 millimeter or so of clearance, if you can see that there. To keep things decently tidy, I'm just gonna... Alright, so it's now time to assemble the bearing stacks, so we finally get to use these. The pins. I should try and design parts that actually use these for structural reasons. That would be fun. And these are the bearings. I just yoinked them off the old components. That's the second one complete. That's number 3. Is that right? Yes, sir. Awesome. This is why it's important to make sure everything fits. There we go. That was a nice crunch. Oh, that was even nicer. There's some very neat little design tricks in here. I quite like it. It's a really good experience to build. Now there are 2 of them. You may remember these little things I designed. They just go like this. Once we install the heatset inserts. Oh, easy. Sweet, I've been looking forward to this. Gantry time. More bearing stacks. Okay, these could definitely be a bit better because of my skill, but let's move on. Once again, adding these little self-tapping screws to get the parts together. Now the manual does end at page 27, we're all done. So I'm guessing it's reinstalling everything in reverse. Let's go for it. Quite the adventure, however, every single one of these parts, super strong, super rigid, not bad at all. Alrighty, I suppose I can just drop this part. We need to square that up, of course. I'm pretty sure this machine would be in pieces if it wasn't for this video's sponsor, PCBWay. I've asked them to make a few things over the years, but these laser cut, anodized, and then laser engraved aluminium panels are easily my favorite item, even though it's quite the competition. I've tried parts made with SLM aluminium, SLA clear resin, and even laser cut carbon fiber, with all parts making a difference in my builds. Even all that is just scratching the surface of what PCBWay can do, and if anything, their offerings are worth diving into a bit more. For the rest of the month, they have discounts on TPU FDM printing, so it's worth considering if you need any flexible parts. If you'd like to learn more about them, there's a link to their site in the description so you can see exactly what they can do for you and your projects. Thank you, PCBWay. Not 100% sure how this goes. Surely this does actually work, right? Oh, these are much bigger than I thought. That makes sense, yeah. I do wonder what the benefits are to using these square ones over the regular hex ones, but yeah, I'm sure there's an easy Google answer there. If it's something like simplicity is better, or I don't know, I'm gonna be very amused. Oh, it is now hot end installation time. Let's grab the hot end. Yeah, here's the Dragon Ace. Now I did destroy the block in the last video, but I did buy a separate, did I say block? I meant sock. I did destroy the sock in the last episode. We are gonna be replacing the nozzle though, so I'll leave it all as is. Hello? Are we rolling this time? Third time's the charm. You may have noticed that I've made some progress. I think my SD card was dying. This is the third SD card I've tried. It's not even a real, it's a micro SD card from my audio recorder. We did install the hot end, we installed the belts, we installed the Orbiter V2. I think I said some stuff about something, I don't know. I was talking about the hot end, and I wanted to say that Triangle Lab packaging is absolutely in a league of its own. That was something I wanted to say. I did have a side note. I got an air compressor that's hopefully going to be relevant unless I ordered that too early. I think that's everything. I installed the top beams as well. Yes, yeah. I just really hope that this recording actually saves because I lost a lot of footage. And that's never happened before. Never lost photos, never lost videos until now. Camera's about to die. I hope that was a good enough recap. The following sequence is rated NES, or not even slightly scientific. Please take with a grain of salt. Now, let's address the elephant in the room, mounting these things to the printer. I know there's a mod out there that I should have gone with, but I wanted to try decoupling the motors as practice for my custom printer build. Because of this, we've introduced a new factor, which is the material for the shaft that couples the motors to the pulleys at the top. Here are the three materials on the table. Aluminium wasn't even considered. We have carbon fiber, grade 5 titanium, and high-speed steel. In terms of cost, the carbon fiber I bought, because of the set of 5, was cheaper than the steel, and most expensive was, of course, the titanium. A new term I recently learned, however, called shear modulus, was the real kicker here. Shear modulus, or otherwise known as the modulus of rigidity, is the measure of the rigidity of the body given by the ratio of shear stress to shear strain. What does that mean? I honestly don't know. I'm not really qualified in any way to explain, and I'm not saying that I even do understand it. Essentially, the simplest way I'd like to put it is if we put all the rods vertically, like this, and push them, the ones with a higher Pascal value will resist it more. With such a crude test, I'm not proving anything here, but ultimately steel does come out on top, followed by titanium and then carbon fiber. I'm guessing that's just how the composition of carbon fiber is. It doesn't work very well for this application. Steel was the winner from the start. Before we install our winner, we have a few more components that we need to grab. Well, some idiot I am talking about whatever I was talking about, I don't remember. But this coupler doesn't take advantage of the flat spot on here, so oh no, I didn't think about that. Of course I didn't think about that. No, I'm too far in. There's got to be a solution here somewhere. Okay, I've done some thinking and I've come up with two solutions.
One being better than the other involving theft. You are coming with me.
Using this one as an example, the issue is when I spin this, I think it's not eccentric. I think that's the right word. It's not perfectly eccentric. Plan is to, of course, the double shear is going to be there, but I was thinking of having another bearing down a bit. And that's why the shear modulus is so important, because this is going to be under a lot of pressure. Yeah. I'm hoping that this will be effective enough for the pulleys to all work fine and not get varying levels of tension. And I apologize to anyone I've offended with this topic, because I know nothing about it. Oh, this is funny. Not only did we need to commit theft to get that working, get out of the way, Lite, we need to commit theft on that machine too. Oh, this poor machine. Sorry, Kraken, you're coming with me. All right, let's get some of these components out. If you guys could see the haphazard camera rig that I've built up to get the camera up here. Love it. Oh, and here's that rig. Oh, that's hilarious.
Visually, I don't think it gets much better than this. Seeing all the mods installed on the V0, Nema 23s, the Kraken mainboard, I absolutely love it. For these first few prototypes, I'm going to use Anycubic PLA Silk Blue. And in case it wasn't mentioned earlier, Anycubic is supporting this video and the next with a bunch of spools of filament. Now this looks like it lives up to its name. For now, I want to get these, which means removing these back extrusions and cutting them. We got there in the end. They turned out pretty decent. These are the largest heatset inserts I've ever used. They are M5 heatset inserts. They are 7mm tall, 7mm wide. This part, but a few millimeters thinner and made out of aluminium, maybe even anodized red or blue or purple, would look absolutely amazing. But yeah, we can deal with our 5% infill prototype for now. First bolt, second bolt. And now we need to add some M3 square nuts in there. Alrighty, now we can finally install this top piece here. Lots of mounting points. But even though it's like really light infill, it feels very rigid. It just got even better adding these bolts here and here. Like this thing's not going anywhere. And this is like 5% infill once again. Well, installing them shouldn't be too hard. I just take it, put it in like that, yeah. Nice and easy. I sorted through the majority of M5 hardware that I have, and while I have the most of these are actually the perfect length, so that's what I'll be using. Yeah, I think this was a good call, using the heatset inserts and bolts from the bottom. Now, I know I did all this talk on the stainless steel rods and carbon fiber, titanium. This is still stainless steel, but it's already ground. It's a bit shorter. That's why the mount is a lot closer. There are some like issues. I don't know if this thing is like completely eccentric or concentric or whatever the term is, but it doesn't rotate perfectly, if that makes sense. Not as aligned as I wanted it to be. Oh, okay, the issue is one of the bearings is not making this aligned. However, on the topic of this, what I should have done is used these, I think 20 teeth, and they have 8mm bores. So I could have just extended the shaft with an 8mm one instead of 5mm. So yeah, I've made this a bit more complicated. There's always these little things that I never account for. I'll get better at that. Oh, this is awesome. And the second one is looking a lot better already.
and we're good to go already. Now that is fun and all, but we still need to install the pulleys, so there we go. Alrighty, it's time to get serious now. I've got the connectors and I've got the housing and I've got the wires. High hopes. Make sure to never crimp onto other connectors like some people. Old connector. I'm gonna do this. Yeah, not recommended. That wasn't hard at all. Now we have our 4 connectors that we can install into the casing. That is very rewarding to see. I just hope they're correct. And yes, the Kraken mainboard is overkill, but it can drive the Nema 23s easily, no problem. The Nema 23 connectors will return, but later in the custom printer arc. Alrighty, it is now fancy transition time to getting all of this wired up. Then we can start moving. Well, I'm pretty sure the wiring is done. I'm decently confident in it, so let's plug a cable in. Okay, well, I'm expecting a Christmas tree regardless of if this works or not. Looks like we're in. Alright, well now I need to spend a day getting the firmware sorted, which is going to be a little bit tricky. But yeah, let's cut to something important. I'm just going to click the Home X button. Did something move? So now I need to figure out why the motors don't spin after that happens. I've swapped the 2 middle wires on the X stepper, so this should hopefully work now. Nothing. Alright, 3rd time's the charm. Let's click it. Did it move? Okay, 4th time's the charm. I've rewired everything because it was likely backwards. Not again. If this doesn't work 5th time, I don't know what to do. Okay, where to begin? I'm not mad, I'm just disappointed, but the 2 Nema 23s in there, they're dead. Completely dead, burnt out. 0 ohms measured. Because I tested with a fresh one was good, so unfortunately I was very confident at the start, and I did have the wiring right, it just was entirely backwards. Long story short, I have the new parts for the back, printed on the Creality K2 Pro. I have officially run out of space, by the way. I am completely out of space in this studio. Oh, that's so frustrating. I'm just gonna install the new ones correctly. Now, I have heard that PLA can be a bit more rigid than, was it ABS? But this, ABS GF, with the bolts here, and all that, not even all of them, is insane. There's no flex. I can't even show it properly. There is no flex. Well, actually, the paperweights, I'm going to keep them as just in case, but I'm only going to wire one of these now. Just one. My confidence is a little bit shattered, but I'm still very confident. 3, 2, 1. You're joking. It reads 0 ohms. Everything is correct. This is the B coil is going to B, and the A coil is going to A. What on earth is going on? So I don't know what to do now. I don't want to make a video and upload a failed video. What do I do? Okay, I'm actually terrified, but this has to work first try. Did it? I'm genuinely just like stumped. Never mind, no I'm not, just needed more current. That is the biggest relief ever. The issue explained was that I disconnected some of the coils when wiring the motors in bipolar serial, so upon fixing that, the motors did read a resistance, and upon wiring in bipolar parallel later on, which is the one using all of the wires in the connector in this shot, we can run higher current with less inductance and resistance per phase, which will be better overall. This was recommended to me. I hear bipolar parallel wiring is better for faster printing too, as it maintains the torque at higher speeds, which we of course want and you'll see in action. So I think I can improve that with even more tuning with the sensorless homing, but if this was a wired end stop, I think we'd be fine.
These nozzles are actually very similar, which makes sense. They're both from Triangle Lab. Although the diamond one I did purchase myself.
While this isn't the highest flow hot end setup, it's very compact and it should pair nicely with our cooling.
And because some silly guy destroyed the silicone sock last episode, I bought a nice new one.
It's test print time.
I'm going to use Anycubic high-speed PLA, purple.
Nothing fancy at all.
Now, technically speaking, it is printing.
And I'm almost positive that this has the wrong E-steps. Let's check. Sorry, rotation distance.
Yep, it's meant to be 4 something. It's currently at 20 something. Rotation distance, extruder 22.23. The manual says 4.637.
Oh yeah, that's looking a lot nicer already.
Every time I do one of these projects, I always find like some new errors, some new niche issues or something. It's all very interesting. What is going on? Wait, I've just realized something. Oh my, I'm so stupid. This is my config. This is my config for the Z. Do you see that? Position end stop 60. There is not 60 millimeters from here to here. Oh, it's been halved. I've been using the wrong. Okay, well that solves everything. Wow! This example config shows micro steps of 32 and rotation distance of 8. Double what we were running. Let's fix that immediately, even though I am a bit curious about this distorted benchy.
And of course, for a little bit of context, this is how it's meant to look.
According to the slicer, this is meant to be the other way, so everything is mirrored. This is just comical. Now that one actually did fail, so I'm going to run off a new version with a few tweaks. More glue stick, and let's do a 10-minute one. And one thing I have actually noticed is the motors. It's pretty good that we installed the thermistors because they are like 50 degrees. Actually right on, yeah, 47, even though the thermistors aren't fully connected, so a bit inaccurate, but well, I've been trying, a bunch of different cables, tweaks, but I cannot get the input shaper to work. I just want to connect to the thing. I do have the values from last time, and I do really want to update them given all these new components, but I don't get why it's throwing a fit all of a sudden. Yeah, I think I'm just gonna have to leave it for now and continue on with the speed testing.
No way. Dude.
Now, because I got these panels laser cut instead of CNC'd, I will have to countersink the bolts, and that's because I bought these absolutely lovely screws, bolts thingies. They were 16 New Zealand dollars, so like 10 US dollars, on like just a few bolts. Oh, that's mad, but they look so good. Yeah, basically a perfect match. Oh, they are absolutely beautiful. So, yep, there's one thing we need to do is countersink everything, but there is one other thing, which is cutting this top hat by like 20 millimeters on each corner, because I designed these panels for the 80 millimeter top hat. This is a 100 millimeter top hat, but I couldn't have possibly known that. It would actually be wise of me to make a 3D printed jig for getting these cut precisely. I won't do that this time, but I'll remember that for the future.
Kind of just have to go for it and then look back after I've done a pass. Now to do it 24 more times. It's looking pretty good so far.
And just like that, we are all done with countersinking the panels. Sweet, now to chop the extrusions.
Well, at least this doesn't require too much thought. I'll just cut and then maybe sand down the rest. Yeah.
That's basically bang on 80 millimeters. Should be perfect. All right, all cut and sanded, good enough. Let's get back up to the studio.
Top hat is cool and all, but I think we should call this the crown. Oh, I love that. Putting on the crown.
I've just simply removed all of the plastic panels from there.
So a little test placement. Nah, that's surreal. I've waited months for this. Absolutely months. I think I should have gone for 8mm screws instead of 6mm ones.
Well, I know for the future that next time when I'm in doubt, just grab screws that are a little bit longer.
There we go.
Wow.
Okay, let's ramp up those speeds immediately. Stepper motors have hit 40 degrees. Everything else is looking good. Hey, that's looking pretty good so far, 7 minutes in. Yeah, we crossed the 10-minute mark and we got pretty close to it actually, so that's great. 11:32. Fantastic for 200mm per second. After I write this guy down. Hey, the motors reached like 45 and 47 degrees. Wow, time to let them cool down as well.
I called it!
Actually, I don't think the belts are tight enough for anything major. That's the issue. And they're already maxed out. I would have to take everything off again. Oh shoot, we've had a layer skip. Oh no.
Can't say I was expecting that.
In bipolar parallel, these motors have a max current of 5.66 amps, so I'm going to run them at 5 and just go for it, to be honest. The motors are still a bit warm though, and I have no active cooling for them. Very interesting.
Well, you know we're doing performance testing when the fan comes out. I'm going to switch things up and try 400 at 60k. See how that goes.
Hold on guys, I don't think it's sticking. I might be wrong though. Okay, the new goal, sub 8. That's what I want. Boom, 839. I know it's a BSO, but 839, I want sub 8. 8:43, let's go!
Yeah. That's an 8-minute benchy, alright. Looks the part. Not atrocious, just bad.
Alright, this time we're going to run 400 at 80k and see if that works. It drives me mad.
Yeah, I think that's so stupid how it like overwrites when you're typing. So I accidentally gave it, what is that, 2 billion acceleration? I don't even want to think about it.
There we go, 400 millimeters per second at 70,000 millimeters per second square acceleration, 20 SCV, 0 MCR, awesome. Right, Unfortunately, I was having issues with the old test speed macro, so I had an idea. I got ChatGPT to cook up this macro that goes from 100 millimeters at 50K, does 5 passes, and then goes all the way up to 2,000 in increments of 100 millimeters per second. Let's see it. Oh shoot, this is actually gonna be terrifying. Okay, we're gonna witness it. Okay. Wait, I'm actually kind of scared. Oh wow. Oh wow. Oh wow. What are we at? 1,400! That's 1,400! 1,500! That's 1,500! That's 2,000! Now, in the moment here, I was pretty excited, but it's important to note that the acceleration of 50K that I was using means that the machine only reaches that 2,000 millimeters per second mark for about 20 millimeters before it needs to decelerate and accelerate again. For 1,000 millimeters per second, the machine maintains that for 80 millimeters rather than 20. Interesting and fun stuff. You can see more about this on Prusa's website with their calculator. Now again, but 75K XL instead of 50K. There we go. That was what, 1,300? 1,300 at 75K? Boom. All right, let's make things a bit more serious. Oh, and this is the extended one. 60K acceleration up to 3,500 millimeters per second velocity. Now we're at 1,000. Whole table's absolutely shaking. That's 1,500. 1,600. I think that's 1,600 at 60K is our limit. Let's try it a bit slower, but otherwise I'm more than happy to call that. I should probably tape my phone down, to be honest. 2,500. Now I think we've reached like a hard limit. 3,000 apparently. I don't even know. It doesn't look real to me. I think it tops out. I think it actually tops out at like 2,200 or something. I was just getting some extra footage, and where was it? This wire from the belt rubbing is completely gone. That's why cable management is so important. I'm gonna get back to getting some more footage though. That sudden stop is terrifying. And these cables are shot. Oh, no, it's just a single one. Ha.
Well, I got the numbers I wanted, I guess. Maybe I just wanted to see the printer explode, to be honest. I think that's what I really wanted, but it's getting a bit late here. It's been a bit too long I've spent on this video. So yeah, that has been Voron Limits. I can't believe this video is finally out after like getting the idea maybe 8 months ago. Time flies. Okay, Tommy, take it from here. Now, quite a lot has happened in this video, and quite a lot more was supposed to, but long story short, with what's coming up very soon, I need to make sure that I take some time off for once, hence the fast-paced video, excluding the total length. For now, I'll try and answer some possible questions here, but if yours isn't answered or you have a suggestion instead, I'm all ears as always, and please leave a comment. Rapid fire, why the Voron Zero? Well, being the smallest Voron, it's the most appealing to me as a platform, and modding something like a Trident is more on my post-custom printer list rather than before. Where's the in-depth testing? Well, that's a fair point. With such a unique and big video, there should be more of it, but I haven't done that, and my only defense is I didn't want to invest lots of time into something I expected to combust. Unfortunately, it didn't, and as for quality, the V0 was already giving me great results beforehand. However, I know that the belt tension was costing me points here, as well as the lack of preloaded linear rails, and obviously quite a deficit of good cooling and higher flow. This was essentially a project of ticking one box the best I could and then half avoiding the other ones. Cooling? She'll be right. A big one is the decoupling, and while I did say I want to do that for my custom printer build, which is why I mimicked it here, I think I've learned a valuable lesson that is blatantly obvious in hindsight, and that's just keep it simple. I'm quite naive, but after realizing the complications that I'm introducing, when there are proven and simpler methods out there, it made me realize I should probably take some notes from the book. I'm giving decoupling one more chance. I just need to spend a week in CAD, but no time for that just yet. It's time to learn CNC machining from scratch and do a big project all in around 2 weeks, hence the rush.
Although ultimately, it's nothing that optimized work and communication can't solve. I get tunnel vision sometimes and worried for basically no reason, but I digress. If you're here with me now at the front lines, thank you for being a part of this journey. I still remember building this machine, I'm looking at it off camera, seven months ago was it? It just happened so fast. This journey may continue in the future, but as for now, the custom printer arc is only a couple of videos away. So as always, thank you so much for watching, and hopefully I'll see you again soon.